Okay, thank God. I just finally made this thing work. So, okay, I just figured, like, I think that maybe some people would benefit from, like, kind of a more in-depth tutorial. So, yeah, I guess I'm gonna do that. Just, honestly, even if one person watches it, then that's fine by me. I don't know. No one has to, obviously, but I'm just like, I'm just comforting myself. Maybe somebody will watch it. Okay, so first step, can I take out a GCF? No, because first of all, I already have to factor by inspection. To factor by inspection, I need a trinomial with the coefficient of the x squared term being a positive 1. That's already what I have. So here I'm just looking for two integers that multiply to -6, which is c, in terms of like this little template. And then we also want the two integers that add to +1, which is my b. So, what multiplies to 6? 6 could be 1 times 6. It could be 2 times 3. And that's it. Because if I start doing 3 times 2, it's like, there's no point. So I've listed out all my possibilities. Can I somehow, well, if it has to be -6, I know that one of them has to be negative. So if I have -2 and +3, does that work? Yes, because they multiply to -6, but they add to +1. So that meets our requirements. And so we can just basically slot those in. Perfect. Okay, let's move on. So that was like most regular version of a factoring by inspection, because you didn't even have to factor out the GCF. Here, step one, always, my step one always is, can I factor out a GCF? Well, yeah. If this was, let's imagine this was a fraction, 8/98. I would know that I can definitely factor something out. Oh, I can definitely do it at least by 2. I don't know if that's the maximum. Let's see. So 4/49. That is as much as I can simplify. So anyways, but let's actually just break down the terms, because if this is actually a tutorial video, let's just see. So 98. So, okay. I'm going to break down each term into its prime factors, because I might as well go full depth, full detail right now. So 98c squared. Well, 98 can be 2 times 49. 49 is 7 times 7. So that's going to be 2 times 7 times 7 times c times c. Minus 8, that's just minus 1. 2 times 2. Oh, sorry. Let me just make sure. Oh, no, I am recording. I can see there. Okay. So the reason that I put that factor of -1 there is just because it's negative. So I just want to have that there so that if I were to multiply all these factors together, it would become negative. So all of that to say, what's common? Well, there's a 2 and there's a 2. That's it. So that tells me that my GCF is 2. So basically, I'm going to take the 2 out front, and I'm going to see what should be left over when I have divided each term by that GCF. So that's going to be 2 times 49c squared minus 4. Interesting. Okay, we took out the GCF. It's not a trinomial. I'm not going to be doing factoring by inspection, but it's a binomial. It looks like I can do this for the difference of squares. Difference of squares equation. Difference of squares equation is a squared minus b squared equals a plus b times a minus b. So basically, anytime we see something squared minus something squared, we know it can work out like this. So what is being squared here? Well, if I had to go in and be like, okay, well, what's the square root of... I know the square root of 49 is 7. And I know that the square root of c squared, let me just write these things out. I don't know. It's like we don't always have to think about it in so much depth, but just to explain what's happening. Square root of 49 is 7. Let me just break it down like this. Okay, so square root of 49 c squared is going to be the square root of 49 times the square root of c squared. 7 times 7, c times c. Well, that equals 7, that equals c. So it's 7c. It's as if we have 7c being squared, and with 4, I know it's as if I have 2 being squared. Great, I have an a squared and a b squared, so I'm going to basically rearrange. Well, or arrange the way I need to arrange. 7c plus 2, 7c minus 2. Okay. You don't have to necessarily show all of this work. You can just show yourself factoring out the GCF. Like, it's not about this. It's just I'm going in depth right now because, I might as well do that. Okay, so first question. Do I have a greatest common factor? Let's do our prime factor thing here because maybe it's confusing or something. So the terms that we have are, I'm just making sure that c to the power of 9, a to the power of 9. So first of all, they're both negative. So I can put that little factor of -1. I kind of feel like I need to just do my factor trees because I can't really just pull these factors out of my head, personally. Okay, so it's, oh shoot, I'm gonna wanna move that because otherwise it's gonna be getting in my way. I'm just gonna write small. I don't wanna move that right now. Should shut this app just in case. Okay, so -20, -1 times 2 times 2 times 5 times C times C times A times A times A. Okay. This is gonna get a bit crazy. You know, okay, I will just move it. You gotta do what you gotta do. I'll make it tinier. Oh, that's nice. Because I know I'm gonna need a bunch of space over here. So, okay. Times, what was it? Oh, whoops. Draw. Times, what? Times 2 times 5 times 7 times C 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 times A 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 times A. Okay, so what's common? Well, I know -1's common. 2 is common. 5 is common. 2 C's and 3 A's are common. So that's what I want to pull out. My GCF is going to be all of those factors multiplied together. Which is -10, -10 C squared A cubed. So I pull that out front. So I start with -20 C squared A cubed minus 70 C to the power of 9 A to the power of 9. And I basically pull out a factor of this. And what I need to do inside the brackets is basically divide each term by that GCF. Okay, so all of that to say that we end up with this 2 plus 7C to the power of 7 A to the power of 6. So that's like, and here's the thing, this isn't a trinomial that's factorable by inspection. It's not a difference of squares either. So that's that. That is the end of that. Sometimes we just take out a greatest common factor, and that's that. Yeah, so, okay, let's move over wherever it is I need to be. Okay, the issue here is to factor by inspection, we need that +1 coefficient, which is actually the leading coefficient. We literally used that word last chapter or whatever. So honestly, leading coefficient. And the issue is we don't have it right now. We have a -1. So basically what I'm going to do is factor out a -1. And then show myself dividing every little term in there by -1. The effect of this is that all the signs flip. So that term becomes positive, this term becomes positive, this term becomes positive. And then, fantastic, we have what we need. We have that +1 leading coefficient on the trinomial. Two numbers, multiply to 14 and add to 9. Well, 2 and 7. +2 times +7 equals +14. +2 plus +7 equals 9. So that tells us everything we needed to know. And x plus 2, x plus 7. It can be a -1 there, or you can just write it as that kind of thing. Because effectively it's like the same thing. So there we go. That's that. Okay. Almost done. First question always. Is there a greatest common factor? Yes. I can definitely at least factor out a 2. But is there anything else I can factor out? So, you know what? Let me just show the factor tree, because it'll just make more sense that way. You know what? It'll save me time if I don't always do the arrows. 4 times 6. It doesn't really save me that much time. So basically the prime factorization there is 2 times 2 times 2 times 3. Perfect. 150. $150, 3 times 50, 5, 10, 2, 5. Okay, so basically, yeah. All right. Oh, whoopsies. So 24x squared is basically 2 times 2 times 2 times 3 times x times x. -150 z squared is going to be like 2 times 3 times 5 times 5. 2 times 3 times 5 times 5 times z. So anything that's common, oh, it's a greatest common factor of 6. Okay, because there's a 2 that's common in both. There's a 3 that's common in both. And that's it. So my GCF equals 2 times 3 equals 6. All right, so then I do the thing, I pull the greatest common factor out, and I basically want to divide 24x squared minus 150 z squared. So four x squared minus 25z squared. And first of all, it's not a trinomial. I know I can't factor that by inspection, so that's out of the question. My only other question is basically, can it be difference of squares? Well, yes, it can. So 4x squared, square root of 4x squared is 2x. Because 2x times 2x equals 4x squared. Square root of 25z squared is 5z. For the same reason, 5z times 5z is 25z squared. So basically, that just means I can write this as something squared minus something squared. 2x squared minus 5z squared. Oh, whoops, sorry, I have to keep including my 6, because otherwise I would be getting off track. I've got to keep that GCF out there still. Okay, and then by the difference of squares equation, this is my A, this is my B. That means 2x plus 5z times 2x minus 5z. And that's the end of that. All right, and then finally, great, another straightforward little trinomial, because see how leading coefficient is already positive 1. That makes me so happy. So happy. And then basically, like, yeah, it's just regular old trinomial factoring by inspection. Multiplies to 20 and adds to -9. Well, 1 times 20, or it could be 2 times 10, or it could be 3 times nothing, 4 times 5. Oh, interesting. Interesting. Positive 4 times positive... Oh, wait, sorry, I'm messing up so bad. Negative 4 times negative 5 equals positive 20, because negative times negative is a positive. But negative 4 plus negative 5 is -9. So that fits the bill. Perfect. Okay. I guess that was that. So, yeah. You want to be able to do these types of questions. So please ask for help if you need any help. Always factor out the GCF first, and then pretty much it becomes clear, am I dealing with inspecting or factoring by inspection for a trinomial, or am I dealing with a difference of squares? And those are the only things we covered in chapter 4. So those are the only possibilities on the table. Okay.